Okay, in this segment we're going to use what we learned in the previous segment. So if you're all saying, where would I ever use these pointers and addresses? That's the right question, and there is an answer. So we're going to look at functions in C again and use the pointers specifically for passing things to functions. Okay, so this is starting out revisiting functions. I'm going to describe the function prototype. So C compilers start at the top and look at your code from top to bottom one time. And a C compiler is called a single pass compiler. Your functions need to be defined before they're used. So when we start out learning about functions, we put all the functions at the top so that this function foo, for example, is known about by the time we call it. So the compiler, when it comes to this line, it has already seen the function foo. A function prototype goes at the top, and some people call this a look-ahead. You define in a function prototype the return type, the name of the function, and the data type of the parameters. So now we have, when the compiler looks at this code from top to bottom, when it comes to this line, the compiler knows that there will be a function foo that takes an integer because it saw this function prototype, the look-ahead, and then we can put the sub-functions down below. So that's the purpose of the function prototype. Okay, now we're getting close to where we're going to learn about passing parameters using pointers. This isn't one. This is an example of calling a function with a parameter that can't be changed. So the name of the function is cannot change me, and it takes one int parameter. When we pass the variable a into this function, we pass in the value 10. So look at the function call. The name of the parameter is param, and we assign that local variable to 27. So here are the pictures. A in the main method has the value 10 in it. When we step into the function cannot change me, we have a local variable param. The value 10 went into the parameter. And then when we change the param, the local variable, to 27, you notice that the variable a in the main doesn't change. So we're changing that local variable. That means that the value 27 is not going to get back to the main. So information is being passed into that function only. Okay, let's revisit now what we did in the last segment. We declared a variable a, and then we declared a variable of type int pointer, and we allow PA, which is an int pointer, to hold the address of a. And then when we say, go to the address, what's pointed at by PA gets 27. What we're saying is go to that address and put the number 27 there. So we remember that from the previous segment. And when we put 27 at that address, the variable a changes. So we're going to look at how we would use that when we try to get information from a function through the parameter. So we have a new function in this example called canChangeMe, and the data type is an int pointer. So let's look at the main method. We have that variable declared a, and we put 10 in it. When we call the canChangeMe function, instead of passing in a, we're going to pass the address of a. The address of a is what data type? It's an int pointer. That matches the data type of the parameter. So in the function canChangeMe, we have a local variable called pparam, and it's an int pointer. So what gets passed into the function canChangeMe? The address of a, which is 385FD6, just as an example. It's the address that gets passed to the function. Now when we're inside the function, we say, go to that address and put 27 there. And what happens when the function returns? A will have a new value. So do you see what happened? Instead of passing in the value of a, we passed in the address of a. Inside the function, we went to that address and put a number there. When the function returned, the variable had been changed indirectly. So we have two ways of passing something to a function. We have a pass by value, which is what we saw in the canNotChangeMe function. That was information going in only. We passed information in, but no information came back to the caller. In this example, we pass information in by passing in an address, and we get information out by putting something at that address. I think what we need to do now is go into the development environment and actually type these two functions, walk through them in the debugger, and see what's going on. Okay, so we're in the development environment now, and we're going to play with writing functions that use pass by value and pass by reference. So these are the same examples that we looked at in the slides. If we type them and walk through them in the debugger, then it will just bring this point home, I hope. So if we're going to make a void function, that means a function that doesn't return anything, and we're going to call this cannot change me, and it's going to take one parameter and it will be an int. So that's called the function prototype, and that allows us to put the function down here. And I don't know if I'm using the exact same names as I used on the slides, but it doesn't matter. Notice that the difference between the function definition and the function prototype is that you don't need the name of the parameter in the function prototype. You just need the data type of the parameters and the number. If you want to put the name of the parameter there, you can. Some people do that for documentation purposes. It's easier to read this sometimes if you know what the intention is of passing in that, or each of the parameters if you've got more than one. So in the main, let's declare a variable a and put 10 in it, and then we'll call the function cannot change me, and we'll pass in the variable a. So inside the function, what we're going to do is assign parameter to be some other value like 27. So the point here is when you come back from that function, what is in the variable a? And you can guess by the name of the function that the variable a still has the same value. So this function call cannot change the value of the parameter. So this is, in C language, any primitive variable that you're passing to a function will not be information coming back out of the function, only information going into the function. And it's called a pass by value. Let's put that in there as a comment. So let's run this, just make sure we haven't made any mistakes so far. And as we expected, a has 10. So now right here in this same file, we're going to make another method called canChangeMe, and the parameter is going to be an int pointer, which means we're going to pass the address of a variable. So let's make the function definition here. Oh, if you defined your function prototype, and your function call all have to match. So if you say you're going to have a function that takes one int, and you call it without giving it an int, then it's not going to match. So you'll get an error message saying too few arguments. Let's make the distinction between an argument and a parameter. When you call a function, you pass arguments. When you define a function, you give it parameters. Some books don't actually have this wording correct. People are using argument and parameter interchangeably, and they shouldn't be. They're quite different things. Okay, so we're going to make a function called canChangeMe, and it's going to take an int pointer, and I'm going to call this one pparam. And this time we're going to use the dereference operator inside. We're going to say what's pointed at by pparam gets 27. After we get this working, we'll step through it in the debugger and make sure that everyone understands what's going on. So let's make the call to canChangeMe, and instead of passing in a, we're going to pass in the address of a. So the address of a, remember, is one of those big ugly numbers. So we're passing in an address, which is the same as a pointer. And the parameter in the function is a pointer data type. So ampersand a matches an int pointer. Some of you have been wondering why I put the asterisk next to the name of the parameter as opposed to next to the name of the data type, and it doesn't make any difference. These are functionally the same, but this one, if you write it this way, you're thinking of asterisk pparam as an int. And if you put the asterisk there, you would be thinking of pparam as an int pointer. Those are exactly the same things, just slightly different ways of thinking about it. Okay, let's duplicate this line where we output the result, what's in A, and we should see when we run this that the first function call does not change the value in A, and the second one does. Okay, so in this, okay, You guys have been using pass by value and pass by reference since the very first class, and you didn't really know it. Let's do a printf, enter a value for a, and now we're going to write a scanf, %i, what goes here, and what does the ampersand a mean? The address of a. So look at the printf statement where we output the value of a, and compare that to the scanf statement function call where we are expecting the variable a to be changed. So does a printf statement change the value in the variable a? It can't, because it's a pass by value. And what is in a after the scanf returns? Whatever the user inputs. So by looking at the code, you can't tell what the value in a is, and that's the objective. That's what a scanf does. It changes the value in the variable. So you have to give it an address, and it's an address where you want scanf to put an int value. That is the reason for that. So from now on, we're going to pass in ampersand a. We're going to pronounce this as we're passing in the address of a. And if you wanted to write a scanf that would input or change the value of 3 variables, we now can write a function that can change multiple variables by passing in multiple addresses. So lots of int pointers if you want a function to change more than one variable name. So here's a functionality that we've gained in the language by passing addresses as parameters instead of passing values as parameters. We can now write a function that can change more than one variable, or it can give you back multiple pieces of information. I'm going to compile this and declare B and C. Okay, let's look at some of the things that can happen wrong with this. You would like C to help you, but C doesn't help you. So, for example, suppose instead of passing in the address of an int, you pass in a number instead. Okay, is this going to compile? Why does it compile? The function clearly says it wants an int pointer. It wants an address. And we gave it 1, 2, 3, 4, 5. What is an address? An address is just an integer value which is a physical location in memory. When we run this code now, what will happen? It'll say go to that address and put the number 27. That's a problem if Microsoft Office or Microsoft Windows is using that piece of memory and you're saying, I want to put 27 in the middle of the operating system. So that would be fun. Why don't we just try that and see what happens? An unhandled exception at this address in our program. And let's break. And it even points to the line of code where it thinks you accessed memory that you didn't have the right to. In the old days, that would be the blue screen of death. And in newer operating systems and newer development environments, it will check if you're going outside of the memory that you have allocated for your own use. Okay, let's set a breakpoint right here on our first function call, pass by value, and allow the debugger to show us everything that's going on. So if we run in the debugger, which is the green arrow, and we hit the breakpoint, that means that we're looking at a line of code that we have not yet executed. So in the autos down here, actually it's a little easier if you look under locals. So in the debug window, look under locals. What variables do we have that are valid in the locals window? We have a variable A with 10 in it, and B and C have junk in it. So we're going to step into this method, cannot change me. Okay, so when we step into can change me, we're stepping in with an address, even though this address is not valid. So I'm going to step in, and what was passed into pparam? Okay, we passed in the number 1, 2, 3, 4, 5. So I'm going to change that back to the way it was, where it should have been if we pass in the address of A, and I'm going to rebuild that. Okay, so where are we putting the value 27? 12FF60, we're going to that address and putting 27 there. And so when we come back, we can see that A now has the value 27 in it. When you're in the debugger and you're stepping through and you want to watch something. So you have under the locals, you have all of the current local variables and their value and their data type. Suppose I want to know what is the address of A. If you open a watch window, you can actually enter something that you want to see. So if I say I want to watch the address of A, I can watch anything I want. If I want to watch A times 256, it will calculate that for me. So anything you want to watch, any expression that you want to watch as the program executes, you can just enter that in the watch window. It's really very useful, and this debugger allows you to do some things that are kind of scary powerful. If you want to watch for an occurrence as the program is running, so if you've got 10,000 lines of code and you want to watch where a variable gets changed, you can set that and it will raise a flag and tell you, hey, look, the thing that changed has changed on that line. Okay, we're going to leave this segment now. Okay, so let's just summarize what we covered in this segment. We revisited the idea of making functions, and we talked about how to make a function prototype so that the order of the function isn't important. Up until now, the only way to get information out of a function was to use the return statement, and that was to return one piece of information through the return type of the function. In this segment, we looked at how to pass variables by value, which is what we've been doing up until now by passing parameters by value. You have information going into the function only. And if it's in only, that means that the function cannot change the value that's being passed in. No information gets back to the caller when you pass a parameter by value. When you pass a parameter by reference, information is going in and out of the function. And to pass something by reference, we pass a reference to a piece of data, or the address of a variable, or a pointer to a variable. Those are all the same thing. So here's an example. When you call scanf, you pass the address of A, which is a reference to the variable A, and scanf's job is to put something in the variable A. In this case, it's what the user types. So the calling function has the variable A changed. So we think of that as information coming back to the caller through the parameter. The only way a function can pass information back to the caller through a parameter is by using an address. So the caller will give the address to the function. The function will put something at that address, and that's how the information gets back to the caller. When you dereference a pointer, use the asterisk in front of a variable whose data type is a pointer type, then you use the piece of memory that's pointed at by that pointer. So what's pointed at by is a good way of reading the asterisk operator. This is a very critical point in learning C programming. I really encourage you to re-watch the segments on the concepts of addresses and references, the asterisk and the ampersand. Get a solid understanding of these because they're going to be used from here on in everything that you do in C and in C++. So have a look at these segments again and make sure that you really do understand them and practice typing the small examples that were given here. I hope you're enjoying this, and I'll see you in the next segment.